Hello, my name is David Buchanan from Vision and Control. I'm responsible for the vision systems, and I would like to show you how to create a simple inspection program and how the subroutine is intended to be. So we start from scratch. In the beginning of the program, we need some structure. So I think it is very useful to start with a small main loop that can be accessed through the time and call from there subroutines with good and bad. So basically, I need the branch command here to make some labels first. So here you can see in this command we have here the option to set a label. If we just give it here, like start, or we can also jump to a label or call a subroutine. So the subroutine, in difference to a jump, has the ability to return back to the point from where it was called. So basically, we start with a start label and insert it in our program. So we see it here as first command. In vcwin, it is possible to just copy and paste, like most Windows programs with Control-C and Control-V, to have just a copy of this label and be able to open it. The start is already inserted here because I copied it. And now I can select the jump condition and make an unconditional jump to the label start. So you can see we have now made in this small program just an empty loop from start to itself. So that's our main loop. In this main loop, I would like, of course, to grab an image first. So we are starting with grab image. It's a little bit hidden here by the video tool, but however, you can see here execute grab image. This will capture an image from the camera 0, the full image, so that's not an image area, otherwise I would have to select this option, and click OK. So we have inserted this command in our loop. So if we execute it, we will see that it is executed all the time, and I can see the command results here in the bottom left, just here, when I press F7 to execute the simple commands. As next command, I want to, I want to grab a clear image. So great. At next, I need to insert a pixel count command to just call some simple functionality. Of course, there are more commands available in the system of various types, but pixel count is very simple to explain, so I chose that one. We can see we have two tabs here. One is teach in. That is more or less used for adjusting this search area where the pixels are counted. And there's a parameters tab, which defines which gray values will be counted. So at the moment, we see all pixels between 80 and 225 are counted inside this rectangle. If I push the test button, it will also highlight me the found pixels. So you can see the quantity of found pixels is 16,844. And on the bottom, we can see where the result is stored. So here it will be stored in the system memory in result with number 0. And it is given at the moment a nominal quantity of 0 and positive and negative tolerance of 1000. So the basic result with this 16,844 found pixels is negative, so the pixel count is out of tolerance. So if we want to change that, we can of course add, for example, 16,000 as nominal value. I just leave the tolerance as it is. So if we hit the test button again, we receive the pixel count result, no errors. So that's great. But of course, the area we are counting pixels are not very specific. It's just a default area. So we can switch to the Teach In tab. And from there, we can select different types of geometries we want to search the pixels, and I just keep the rectangle now. And on the bottom, we can see there's some position tracking options. So if we want to find the object first and then execute the pixel count command relative to the last position, we can give here a point variable so that it is moved according to the found position. I can switch to a more interactive mode by double-clicking right to this label. So here's written mouse switching with double-click right. So that's the position where I have to click, so I do it. And then the monitor screen will toggle to full screen, and we will see that our mouse is inside the image, and it shows some double arrow here that is showing us that we can move the search area. We can also go to the line and change the size here. So I can use this tool simply to define my geometric area where the pixel command is executed. To leave this mode, I have to click again the double-click right. So the monitor window is toggling back to a window size, and we can set the other parameters in count pixel command. Here I can hit the test button again, and we will see that it counts now the bright pixels, of course, because our given search gray values is from 80 to 255. This are more or less the white pixels here in this monochrome image. You can see that the monochrome images are typical 8-bit coded, so 0 is black and 255 is totally white, and all other values are in between. So we can define different range to search for. To find a proper threshold, I recommend to close this pixel count command and just go with the mouse over the monitor window. So we can see here in this field the gray value of the position where my mouse is. So you can see here in the black area it's 9, and here in this area outside it's close to 255. Probably here in the corners of that image it is a little bit darker, but this can help me to give an understanding of what threshold I should set in my count pixel command. So to look for this black region, so I need to count the gray values from 0 to, let me say, 80, and then it will count all the pixels. What we see now is that the red label from the last executed command is overlapped with a new one. So my recommendation is just to delete the graphics here and execute it again, and then you see it is highlighting all the elements we wanted to count. But of course, the quantity of the found pixels increased. So now we have 439,636 pixels found. That's of course out of our tolerance. So I just type this number as nominal value. Probably it's also necessary to increase a little bit the tolerance to make it not so sensitive to some small changes, and then the result will be also no errors. So I can close the dialog now, and in my next step I want to make some subroutine for a subroutine, I need again this branch command that is listed here. Here you could know that if you know the command name already, you can also simply select your editor and enter the branch name one by one. So BRA, I just typed with my keyboard. So all commands are listed now that contains this BRA. So I can select it from here. That is much more simple. If you know the command names already. So here I can again set a label. I call it good and insert it. I just copy it again with Control C, Control V. Make a return in this case because I want to make a subroutine. So if the execution reached that point, it will jump back to the point where the good label was called. So inside this subroutine, we can now add, for example, some superimpose command. It's here listed in evaluation, and draw some text message. So I select text, and here the label good. I changed the text size. I could change the position here in this area, but now I think it's okay in the top left corner. It's red, that's not nice. So I select green for good. Probably the size can be a little bit bigger, okay. And I also want to output some digital signal. So I select here line IO out 1. Set it to high. For example, I can set here an output pulse, so it will give a 50 millisecond digital output pulse on out 1 if it reaches that command. So now we have a small subroutine for good. To call it, we can insert after the count pixel command against another branch command, and here call it after a successful command. So if the previous command resulted in no error, it will execute this command and call the subroutine with the label good, which is already here inserted. So if I close this, I can read this also clearly. And here we can see if I hit the F7 button, we can just try to execute it. So it will show good. And I continue doing this. I can here reach in my hand, then it's not good. And so it is good. Now we want to add another bad routine. To do that, I can simply copy the good routine and make some small modifications. For example, I changed the subroutine to bad, changed the label and also the color, and I give it out on another output. So now we have a good and a bad subroutine, and we can change our branch command here and make an elsewise case. So we can here add also the bad subroutine. So if the last command was successful, it will call the good subroutine, elsewise it will call the bad subroutine. So we can now execute it again by hand. I just step with F7, and you will see here how it behaves. Now it's good. And my small program is finished. So I can transfer it here temporarily in the memory to test it autonomously. So and I can just see here the result and verify it. So that was my small video already about the basic program in vcwin. Of course, you can also not only check these branches after a single command execution, you can also use condition blocks. To do so, you can start a condition block, execute some inspection commands, and then afterwards call this successful block. So it will check a complete chain of commands if every command was successful. Otherwise, it will fail. And with this, you have the possibility to write a small program like find the object, count some pixels, and call a subroutine after the whole block was good. Otherwise, call the bad subroutine. So that's a classical way how to handle problems in vcwin. And I hope you have learned something and you have fun with the next videos. Bye bye.